Okay, so imagine I have the following graph, and we want to know if it's periodic. And if it is periodic, what is the period, if you want? What is the omega? So, first of all, it's definitely periodic, right? You can see it's repeating in blocks. The question is, how big are the blocks? So, let's kind of take a bit of a moment to think about this. If I start from, let's say, here, this position, clearly it repeats in a block of that length there, doesn't it? Okay, so that would be a sensible choice of omega, but unfortunately I don't have the exact numbers here, do I? But I can see, if I repeat again, if I go to there, then I'm actually going to be able to work out what this omega was in the first place. So first of all, I do repeat in this block here, right? Of course I do. And this block has length what? Well, the length of it's going to be, it's 11 minus 3, which is equal to 14. So we could definitely choose omega is equal to 14. It does repeat in blocks of size 2. But it also repeats in smaller blocks, doesn't it? Right? Because if I was to do it with length 14, it's going through this kind of procedure twice. Whereas actually, we only need to do it once here. So this length we could make equal to 7 and 7. So looking at the picture, we can see we may choose. So we can choose. Well, omega is equal to 7. That really is our smallest option here. It's the kind of the smallest possible length where it repeats itself. But it's not unique, right? In the sense that we could equally choose 14. It still repeats in blocks of 14. It's just we're missing a little bit. So when you talk about the kind of the period, the omega of a periodic function, it's not unique, right? Because you could repeat the block several times. But generally speaking, with a periodic function, there's kind of a smallest one. And in this case, 7 is the smallest one. So, not unique. We could choose omega is equal to 14 or 21 or anything like that. 21 would be with 3 blocks, all fine.